Hi everyone, welcome to another video. We are looking today at a brand new function. This is called a hyperbolic function or a hyperbola, in other words. Now this particular thing has this weird equation of y equals 1 over x. So like we did with exponential functions, I'm just going to take this video to really slowly go through what this particular thing even looks like and give us some little tips to understand how we can interpret this and how we can look at what this function does for different values of x and how those affect the y. Now what I'm going to do here is I'm going to draw up a table of values. And it's going to be a pretty big table of values just because I want to get the feeling for a bunch of different places where this function kind of exists in. And we're going to look at what happens with really, really big values of x and then really, really small values of x too. But the places I will be looking at for my table of values is between the points. I'm going to go -2, -1, -1/2, 0, 1/2, 1, and 2. Okay, so I want to substitute all of these in and kind of get a feel for what's going on here. Like with all functions, way back to linear relationships where we just looked at basic lines, we can always set up a table of values to give us an idea of what's happening here. So substituting in -2 for the y, that gives me 1 over -2 or -1/2. Substituting in -1 gives us 1 over -1, which is just -1. Now substituting in this is where it starts getting a little weird. So -1/2, I'm substituting that into here. So let's actually look at what that would look like if I just drew this in. And then we'll see why this kind of looks a bit weird. So this is like saying 1 over -1/2. Now we don't really like to stack fractions when we work with them, because this is where things start to get really messy. But we're just going to think of this thing here, as we do with fractions generally, as being the operation of division. So this thing is like saying 1 divided by -1/2. Now when we divide by a fraction, we looked at this, think way back to when we first looked at fractions back in the year 7 content. When we divide by a fraction, that's the same as multiplying by its reciprocal. So changing this division sign to a multiplication, and the reciprocal of a fraction is just when you flip the numerator and the denominator. So this is like saying -2 over 1. Now -2 over 1 or -2 divided by 1, we can just write that as -2 because any number divided by 1 just gives us that number. So this gives me -2, and then I get left with 1 times -2 gives me -2. So that is going to be my value in here, -2. Okay, a little bit weird, but let's just roll with this, and we're going to see when we actually draw this graph what's going to happen if we took even smaller fractions here. Okay, let's look at the next bit just for now. Substituting in a 0. Now this gives me 1 over 0, but we can't actually divide a number by 0. This, if you try to put it in your calculator, it's going to give you like a math error. So it's not going to work at all. So what we're going to do, I'm just going to draw this little dash here to say that this didn't really work out. This value for y doesn't exist because that would mean having to divide by 0, which we can't do. Okay, now for the next bit, substituting in a half into here, this just gives us 1 divided by a half, and it's going to work in a very similar way to this thing here. The only difference is my negative sign will disappear. So I'm just going to get 2 as an answer. And also put this in your calculators, you'll get the same thing. Okay, substituting in 1 here, that gives me 1 divided by 1, that just gives me 1. And then substituting in x is 2 gives me 1 over 2. Okay, so let's actually draw the initial kind of skeleton structure of this particular function. So I have an axis here, my y-axis, and I have an x-axis too. And I want to map out all of these points here. So I've got 0 here, I've got 1, 2, -1, -2, I have 1, 2, and -1, -2. Alright, sweet. So let's get these in here. So when x equals to -2, y equals to -1/2. So that's going to live about here. This lines up with about halfway between 0 and 1. Okay, our next one is going to be when x equals -1, y equals -1. So that's down here. When x equals to 1/2, so in between here, 0 and -1, when x equals -1/2, I should say, y equals to -2. And we're going to get this thing over here, this point here. Okay, let's pause for now, because we don't really know, we don't really want to start drawing this, because this thing right now is very vague. If I draw so far what we get, I just get something like this, which doesn't really tell us too much. So let's just put in the other values, then we're going to start considering what happens for really large and really small values of x. Now, we said that at 0, at x equals 0, I'm not going to get anything on the y. So we're going to skip this for now. And let's plot in the rest of them. So when x equals to 1/2, y is going to equal to 2. So that's about here. When x equals to 1, y equals to 1. When x equals 2, y equals 1/2. It gives me something like that. Okay, we're gonna draw this in again to here. So that's cool, but like, I don't know about you guys, but this is really doesn't tell us about the big picture. This looks like 2 sort of different graphs sitting in different quadrants. These little, let's write it in here, my first, second, third, fourth. We call an XY plane. We think of this as 4 quadrants. There are 4 little sections which make up my entire XY plane. So my graph is sitting in 2 of these quadrants, and we don't really know much more of what's going on. So what we're going to do is we're just going to try a couple more points, and we'll try to get an idea of what's roughly happening here. So let's try another couple of points. Let's go x, y. Now, what if I try x equals -1/8? And maybe x equals -1/4. X equals to +1/4. And x equals to +1/8. So let's try to substitute these in and see what we get, because that's going to tell us, it's going to fill out a little bit of a blank here that we're sort of encountering. That's what's going to tell us what's happening in this section here in the y, as well as this section here in the y. So in other words, we're finding what happens in the y for these really small values of x. What happens when my x, in other words, approaches 0? So we're asking ourselves this question. What happens to y when x approaches 0? That's the first question we're going to ask ourselves, because that's a bit of an empty piece of our graph for the time being. So we want to see what's happening in these highlighted bits. So what we're going to do is we're going to substitute these values into y equals 1 over x. So my first one, this is y equals 1 over negative an 8. Now, we remember before, this is annoying to do, so let's think of this as 1 divided by negative 1 over 8. Now, when we divide by a fraction, that's the same as multiplying by its reciprocal. So I get 1 times minus 8 gives me minus 8. The same thing is going to happen for the next one. Negative 1 over 4, let's just substitute in 4 for all of these 8s. So 1 divided by negative 1 over 4, that's the same as timesing by the reciprocal of this fraction. That's like saying 1 times negative 4, or negative 4 over 1. But we remember, when we have something over 1, we can just write the number itself. And that gives me minus 4. And this is what's going to happen for the remainder of these values. So what do we notice here? As my fraction gets smaller, so going, for example, from 1/4 to a smaller fraction, 1/8, my y value gets bigger. So when I have, for example, 1/4 here, so if this was my half, this is my quarter, I get 4 in my y. So I get to about up here. Okay, so this kind of shoots up, right? And if we, let's just give ourselves some more room. If we try 1/8, that's even smaller. So that's actually half of 1/4. So let's draw that in. That's going to be down here. That's 1/8. So we're getting really, really, really close to 0, but not really touching it. Because remember, we can't have a value at 0, a y value at 0, because that would mean dividing something by 0, which we can't do. So we're just going to look and see that, okay, when we have 1 over 8, this stretches all the way up to 8 in the y. So we're at 4 at the moment. We have to go double this length. So we're going to go way up to here. So this thing shoots up a little more. And it's shooting up really quickly, almost kind of like an exponential, similar. So it's getting up further and further and further and further, but it's never going to have a value at x equals to 0, or in other words, the y-axis. So this graph, I'm going to write here, the graph never touches the y-axis. Try another one. If you try, for example, negative 1 over 16, see what that gives you. But you'll see that we're still going to get these really high just numbers. This is just going to keep shooting up higher and higher and higher. But we can see that here, this graph never touching the y-axis. In other words, we can say that is an asymptote at the y-axis, or in other words, the line x equals to 0. So this y-axis, or the line x equals to 0, this is actually an asymptote. So as the x values get smaller and smaller and smaller, my graph's going to keep shooting up and up and up and up and up, but it will never actually touch the y-axis. And that is because at this value of x equals 0, my graph, in other words, is undefined. There's no value of y here. It would be mathematically impossible. So we can see this sort of thing happening here. And the same thing is going to happen down here. It's just going to keep shooting in this direction. And you can pause this and have a go at actually plotting those points out. But on both sides here, as my x gets really, really small, my y gets really, really big. So to answer this first question, what happens to y when x approaches 0? We're going to say y gets really big. That is the answer to this first part. Now we also want to see, well, what happens over here for these positive big values of x, as well as these negative values of x as we get bigger, as we stretch out in these opposite directions here. So we're going to try another couple of values here. So we're going to try, for example, x equals 4, y equals minus 4, and we're also going to try positive 8 and negative 8. So let's set up another table of values and try some points here. So we have x, y. We want to see what happens when x equals negative 8, what happens when it equals negative 4, what happens when it's positive 4, and positive 8. So substituting these in, this will be a lot easier than the one before, because my equation here is y equals 1 over x. So we can just substitute these x values just into here. So substituting negative 8 into the x down the bottom, that just gives me 1 over negative 8, or negative 1/8. Substituting in negative 4 here gives me 1 over negative 4. In other words, negative 1 over 4. And the same thing is going to happen for the positive cases. And now I can see that as the x values get larger in magnitude, so no matter what direction, whether it's positive or negative, as the numbers themselves get bigger, so for example, 8 is bigger than 4, my y values get smaller. So the other question we want to answer is, what happens to y as x gets bigger? Or in other words, approaches, for example, positive infinity, so way up over here, or negative infinity, way down on the left hand side. We want to answer this question, and we saw that when x equals to 4, y equals to a quarter. So over here it's at a half. At a quarter, so half of that, this is my point here. There. And then at x equals 8, way down here, this is going to halve again. So it gets even smaller. And you can see that on both ends as well. So here, I'm going to get down to about here, and then it's just going to keep going closer and closer and closer to 0. Now let's just think about this. As x gets really, really, really big, so as it goes from 8 to say 16 to 100 to 1,000, we're just going to keep getting a smaller and smaller and smaller fraction. So in other words, my y is going to approach 0. So up on this end, you can clearly see my y is getting closer and closer and closer to 0. That's coming down from the positive end. It's approaching 0. Coming from the negative end, it also approaches 0. as I go to negative a 16th, or negative 100th, or negative 1000th, it's going to get really tiny, very small, and it's going to get really close to 0. So we're going to write here y approaches, when x gets bigger and bigger and bigger for my hyperbola, my y approaches 0. Let's actually write it there, 0. Now, will it ever touch this? Well, no, because the value is going to keep getting massive for x, which means I'm just going to get a smaller and smaller and smaller fraction. But here where my x, for example, on this end, is approaching infinity. But we're never actually going to get to that because it's just a concept, right? So we can't divide 1, for example, by infinity on the bottom. So my y is just going to get infinitely closer and closer and closer to 0, but never touch it. The same thing here in the negative case. It's going to get really close as I get these really large negative denominators. My y is still just going to get really close to x, but never touch it, because I can't really divide this by my 1 by negative infinity down here. I can't really do that. So all we know so far is that as x approaches 0, y gets really big. As x gets really big, y approaches 0. These are the two relationships we notice. So we said the graph never touches the y-axis, so there's an asymptote at x equals 0. But then over here as well, over here, the graph never touches the x-axis. Or in other words, the line y equals 0. So these are the characteristics of my hyperbola. So my hyperbola looks, if I zoom out, kind of like this. It has these two curvy bits like this, and it has two asymptotes. So one is going to be an asymptote at x equals to 0, this vertical line or the y-axis, and it also has an asymptote on the horizontal x-axis, or the line y equals to 0. This is the basic shape for how our most easy standard hyperbola looks. This graph of y equals 1 over x. Now obviously we're going to look at some transformations here as well, but this video was just a really slow introduction into getting us to really understand how this graph works. And it involved us investigating these really tiny values of x and seeing what happens in the y, and these really large values of x and see what happens in the y. And we get this general shape of these hyperbolas. But that brings us to the end of this video. Thank you so much for joining me, and I will see you next time.